air arm capability by providing responsive, close air support to the ground commander. The speed and firepower of a modern jet attack aircraft has been combined with unique basing flexibility, thereby increasing the effectiveness of the Marine Corps Integrated Air-Ground Team. In this type of operation, maintainability is an important element to assure that a mission-capable requirement of 75% is met or exceeded. The AV-8B combines the vectored thrust concept of the AV-8A with modern U.S. technology. This technology includes a new, larger wing with a supercritical airfoil, positive circulation flaps to achieve high lift in short takeoff, simple lift improvement devices, or lids, to increase vertical lift in ground effects by approximately 1,200 pounds, and a larger inlet that provides increased engine performance. The major structural elements of the wing, engine doors, forward fuselage, gun packs, strakes, rudder, and horizontal tail are of strong, lightweight, advanced composite materials. These composites are twice as strong as aluminum, but weigh 1/2 as much. A raised and enlarged cockpit is incorporated into a larger forward fuselage, improving pilot vision and providing additional usable space for an advanced airborne avionics system. The crew station incorporates an integrated controls and displays subsystem, which reduces pilot workload. Equipment arrangement eliminates the need to remove the seat for access. The AV-8B has twice the range of operation or payload carrying capability of the AV-8A. 7 weapon stations have been provided, 4 of which are also fuel tank stations. Conventional and smart bombs, standoff missiles, and a 25mm general-purpose gun provide for selective execution of weapons delivery missions, which may require loads in excess of 9,000 pounds. Many maintainability features are incorporated, such as cartridge-installed indicators, 30 days between on-aircraft bomb rack cleaning, no safety pins in parent racks, 3-point pylon installation, and many others. From both the performance and supportability standpoint, the Harrier II combines the experience and technology of McDonnell Aircraft Company, British Aerospace, and Rolls-Royce, in addition to more than 100 major suppliers in the U.S. and the United Kingdom. The usefulness of any weapon system is mainly reckoned by its ability to respond when needed. Maintainability is a prime element that was designed into the AV-8B to achieve this characteristic. From the very beginning of the AV-8B Harrier II program, maintainability engineers established design criteria to achieve the contractual requirement of 16.9 or less direct maintenance man-hours per flight hour. More than 400 maintainability features were incorporated by working directly with design engineering. Some of these features are multiple use of built-in pressure gauges provides rapid indication for simplified turnarounds. One example is the strut and tire pressure gauges. Rapid removal and installation of canopy with no rigging required. Delta P indicators are used on all hydraulic filters to eliminate scheduled replacement. Combined AC-DC fuel boost pumps incorporating single clamp mounting provides rapid removal and replacement. Fuel quantity indicating system with built-in test. No calibration required after component replacement. Throttle quadrant removal without removing canopy, seat, or kick panels. Electrically resettable water jettison valve. No oxygen servicing. Turnaround servicing is eliminated. Brake wear indicators provides rapid indication for simplified turnarounds. Circuit breakers replace fuses. Elimination of dedicated TACAN, UHF, VHF, radar beacon, IFF, and AWLS controls by incorporating them into the upfront control set. These features and others enable a phase inspection package consisting of 4 phases 100 hours apart. Most noteworthy is the elimination of any scheduled depot level maintenance. This was achieved by implementation of design features which lower the incidence of maintenance, enhance rapid fault detection and isolation, enable ready access and replacement, and improved corrosion resistance, the latter by several orders of magnitude due to the use of composites. To achieve ease of maintenance, the aircraft systems must be completely accessible. The Harrier II systems are easily reached through 190 access doors, 118 of which are open from ground level without workstands. Exemplary of such ease of access is Door 1 on the aircraft, the nose cone. This area, accessible through use of a hinged and jury-strutted design, allows rapid access to and maintenance of equipment located in the nose cone and forward fuselage areas. The inertial navigation and air data computer are reached through access door number 8, just aft of the nose cone. These assemblies are cooled by onboard forced air, increasing their reliability and minimizing their need for maintenance. When assemblies need to be replaced, quick disconnect electrical connections permit rapid removal and replacement. Swing bolts allow rapid removal and replacement of weapon replaceable assemblies, which slide in or out of their assigned locations. Frequency of access was the criterion employed at the design stage for specifying the type of access door fasteners. For example, areas which require access at 40 flight hours or less are secured by quick-release latches. Where access is required between 40 and 400 flight hours, high-strength quick-release fasteners are used on access doors. For areas which require access exceeding 400 flight hours, structural bolts and screws are used. Aft of the main landing gear, there is a daily access door. This is a centrally located quick access area used in missionizing the aircraft by entering secure voice and IFF codes and loading weapons codes in the store's management computer. Significantly, the AV-8B Harrier II, unlike the majority of fighter aircraft, can be towed and spotted with all access doors removed. Once again, all these access doors make the AV-8B a highly maintainable aircraft, an available aircraft, a weapon system possessing an extraordinarily high rate of readiness to respond. High reliability, low maintenance, resulting in a weapon system mission-capable rate of more than 75%. The United States Marine Corps challenge for the AV-8B was to improve readiness, increase effectiveness, and lower cost of ownership. Response to this challenge by McDonnell Douglas was to produce a weapon system of high reliability, requiring low maintenance, while still enjoying the application of good program management. Typical of the management approach to the AV-8B program was the formation of the Support Equipment Advisory Panel, called SEEP. This panel is a unique McAir innovation, not called for by the contract, which allows direct interface by McAir with 15 U.S. Marine Corps and United States Navy agencies. The major value of SEEP is that it allows operational experience to be brought directly to bear on the program, particularly in the early stages of the program. Moreover, the McAir support equipment maintainability activity achieved design improvements over the AV-8A in the organizational support equipment, which resulted in a squadron GSE weight reduction of approximately 6,000 pounds. Additionally, this improvement resulted in a GSE storage space reduction of approximately 1,000 cubic feet. One of these design improvements has resulted in the development of a three-point jacking system for the aircraft, replacing the four-point cradle concept used with the AV-8A. This new jacking system is simpler, weighs less, is composed of fewer parts, and allows the aircraft to be jacked in a minimal amount of time. Moreover, operation of the system can be performed by fewer personnel. Finally, the jacks themselves are existing items of Navy ground support equipment. Consequently, design and fabrication of new GSE items was avoided. Throughout the life of the AV-8B development program, close customer-user contact has been encouraged and maintained. This has been achieved through frequent informal and formal meetings, seminars, and inspections. This has allowed the customer user to closely observe and verify maintenance features of the weapon system firsthand. Typical of the formal verification type meetings was the Maintenance Engineering Inspection, or MEI. The AV-8B Maintenance Engineering Inspection, a contract-required event, was conducted April 19th through April 30th of 1982 at McAir Facilities in St. Louis, Missouri. The purpose of this engineering inspection was summarized in the opening remarks of the Navy MEI Director, Mr. Larry Cunningham. The objectives of performing the MEI on the AV-8B weapon system are multifold. Evaluate the specific maintenance engineering concepts and procedures to determine feasibility and applicability in the operating environment. Evaluate the adequacy of the ILS and support procedures. Verify the accuracy of the maintenance plans and LSAs. Familiarize the Marine and Navy personnel with the maintenance contractual requirements. During the 2-week maintenance engineering inspection, a total of 49 tasks were demonstrated through performance. Of this total, selected by NAVAIR, 30 tasks involved removal and replacement, 5 involved and required fault isolation, and 14 others required repair or inspection along with related miscellaneous items of maintenance. The maintenance engineering inspection allowed total customer user involvement, verification, and validation of the AV-8B maintenance concept. From this inspection flowed 394 observations, questions, and suggestions in the form of action chits. In 3 subsequent meetings, 96% of the action chits were satisfactorily and mutually resolved between McAir and NAVAIR. But the maintenance engineering inspection is only one milestone along the track leading to evaluated and verified excellence of the AV-8B maintenance program. This is the Naval Air Test Center, Patuxent River, Maryland, site of flight testing for the AV-8B Harrier II. For 18 months, McAir maintainability engineers, NAVAIR, and Strike R&M Division representatives tracked the 4 aircraft assigned to the full-scale development testing activity, verifying the maintenance aspects of the program. Tasks of routine maintenance, specialized maintenance, and the assorted tasks specified as contractual line items have been observed, analyzed, and evaluated. The maintenance evaluation program portion of the full-scale development test program has been successfully concluded. Results have shown that the maintenance man-hours per flight hour have been significantly below the 16.9 direct maintenance man-hour per flight hour as specified by the contract. In August of 1983, AV-8B No. 5, the first production configuration aircraft, was flown at the McDonnell Douglas facility in St. Louis. All test objectives were met, and after further testing and evaluation, the aircraft was delivered to the Marine Corps. The AV-8B Harrier II, an advanced weapon system which is achieving new high levels of maintainability and supportability. Maintainability did not occur by chance or afterthought. It was deliberately and methodically incorporated into the design by the efforts of the entire AV-8B team, resulting in a highly effective, quick-response, modern weapon system for use by the Marine Corps Ground Commander. Exceptional firepower, unique basing flexibility, survivability, and minimum maintenance make this weapon system a combat tool of awesome proportions. The maintainable AV-8B Harrier II, the cutting edge of V-STOL technology, is not a promise of tomorrow. It's in the field now.